to see the non-linear data structure. So data structure of two kinds. One is linear and next one is non-linear. Linear in the sense the data can be added to the data structure in the sequential manner. Non-linear in the sense that cannot be in the sequential manner at the random manner. So not organized in the sequential form. The data item in nonlinear data structure would be attached to several other data elements to reflect a spatial relationship among them. So multidimensional arrays, trees, graphs are the example of nonlinear data structure. For example, to organize employee records in our database, we can use the table representation. So it start from the president and next level of employees, and then the manager level employees with the secretary, and the lower level employees are organized in the tree format. So tree data structure. Tree is a nonlinear data structure which organizes data in a hierarchical structure, and this is a recursive definition. The characteristic features are that each element have several successors. So successors means their children, and except to one, the root does not have the successor, and the predecessor for each element is only one, which is called parent. It can also be example of tree data structure is the file systems and the inheritance structure of the classes. So in the file system, in the sense, in our Windows operating system, each and every folder is represented in the hierarchy. Within that folder we are inserting or saving any kind of file, in the sense that can be represented from the root folder. The properties of tree data structure is only one path between every pair of vertices. There is no two paths between the pair of vertices, and n vertices means exactly n minus 1 edges. A graph is a tree if and only if it is minimally connected. Any connected graph with n vertices and n minus 1 edges is a tree. The recursive definition the recursive definition in the sense pair of R comma S. R is the node and S is the disjoint trees. Okay, from the root we are having more number of subtrees. So the S may be empty because only one root can be present in the tree. The elements of a tree is called its nodes. So three terminologies are parent, child, siblings, in the sense same level of nodes, degree, number of child in that particular node, internal node in the sense between the root and the last node, leaf node is the last level of node, level means each and every parent is represented as the level, height means the longest path from root to the last node, depth is also similar to the height, and forest in the sense more trees are represented as the more number of trees in a single plane is called as the forest, and edge is the connection between the parent and the child, root is the only one element of a tree. So the first node from where the tree originates, that is the root, only one root for all kind of tree. Edge in the sense the connecting link between any two nodes. So n number of edge nodes means exactly n minus 1 number of edges. Parent in the sense branch from it to any other node, that is called as parent. Here the example, B is a parent of D and A is a parent of B and C. Child in the sense successor of a node, that is called as child. For E the childs are I and J. This is a child node. Siblings in the sense same parent, the node more number of nodes from the same parent. Here G and H is the siblings, I and J is the siblings. Degree in the sense total number of children of that node, that is degree. Degree of a node, degree of a tree in the sense highest degree of a node among all nodes, and the internal node in the sense which has at least one child, the non-terminal nodes. Leaf node is the terminal node which does not have any child. Here B and C are the internal nodes, I and J, K and H are the leaf nodes. Level in the sense each step from top to bottom is called the level, starts from 0. Height in the sense total number of edges that lies on the longest path from any leaf node to a particular node is called as height of the node. Height of a tree is height of a root node. For example, height of H is 0, height of B is 2 because from B we are having two elements E and I. Height of A is 3 because 3 nodes from the root to the leaf. Depth in the sense total number of edges from root node to the particular node, that is called as depth. For example, depth of I is from root we are having three things, three edges, so that is called as for I that is 3, for H 2, for C the depth is 1. Path in the sense sequence of nodes along the route. For example, path of I is A B E. From E we can reach I. Subtree, descendants of a node, that is called as subtree. So it can be represented in the list format only. List format and left child right sibling representation. So list representation in the sense two types of nodes, one for representing the data node, another one for reference node. We start with the data node and then from the root node in the tree. Then it is linked to an internal node through a reference node. So two different kinds of nodes are needed. One for the data and another one for the reference. And then if the left child right child in the sense only one representation of the node, data is the one thing and the left pointer pointing to the left sub child and the right pointer pointing to the right left child and the right sibling. So this is the example of left child and right sibling representation. So two kinds of representation, one is using the list. In the list we are having two node representation, one for data and that node is referenced with the reference node. That reference node will have the pointer to the left and right child, and in the left child right sibling representation, data with the left child and the right sibling. Data is stored the value of the node, left child and right sibling refer the left child of the node and the right child of the node. If there is no child at all, those two values are null. So this is a representation. So in this video we have seen the nonlinear data structure, example of table, how we are representing tree and what are the tree terminologies are used. So like root, parent, child, siblings, internal node and the leaf node, depth and height of the tree and what is path, and how we are representing the tree using list and the node representation. List and the tree data structure, list and the two kinds of nodes with the data node and the reference node.